Hey you guys, this is Mr. Millings, and in this video we are going to learn how to do some advanced mass stoichiometry calculations. So let's jump right in and take a look at an example problem. In this example problem, it says that solid potassium iodide reacts with 98.9 grams of lead 2 nitrate. We need to determine the products, balance the chemical reaction equation, and calculate the theoretical yield of the product containing potassium. So there's a lot going on in this problem, which is why this problem is an advanced mass stoichiometry problem. But if we read what's happening here, we have solid potassium iodide reacting with lead 2 nitrate. What we need to figure out first is the chemical reaction equation. Once we're done doing that, we then need to balance that chemical reaction equation, and after that we need to figure out how much of the product containing potassium was formed when 98.9 grams of lead 2 nitrate was consumed. So let's go ahead and start by writing our chemical reaction equation. In this problem here, we have potassium iodide reacting with lead 2 nitrate. So we have potassium iodide reacting with lead 2 nitrate. And so what we're going to have to do first is we're going to have to figure out what the products of this chemical reaction are. So let's go ahead and first write the unbalanced chemical equation for this statement right here. So we have potassium iodide. Potassium, we know, comes from group 1 on the periodic table and forms +1 charged ions. And we typically don't need to write this 1, but I'm writing 1 here in this example problem just to show you what's going on. Iodide comes from group 17 on the periodic table, and all those in group 17 form -1 ions. This is going to react with lead 2 nitrate. Lead 2 is Pb with a +2 charge. This Roman numeral 2 here means that that lead ion has a +2 charge. And then we have nitrate. Nitrate, if you look on a periodic table of elements, is NO3, and it has a -1 charge. And so if we take a look here, we have an ionic compound here, and whenever we have an ionic compound, the positive ions and the negative ions here need to add up to 0, or these two ionic charges need to add up to 0. And so in this case here, +1 and -1 already add up to 0, so we don't need to add any subscripts here. However, if we take a look here, we have a +2 charged lead ion and a -1 charged nitrate ion. These two ionic charges do not add up to 0. And so the way that we get them to add up to 0 is to put parentheses around here and put a 2. So we're going to need 2 nitrates here to cancel out the +2 charge of lead. And so what are the products of this chemical reaction going to be? Well, in an earlier video we learned about the different types of chemical reactions. And if we take a look here, we have a compound plus a compound here. And so this looks like it's setting up to be a double replacement reaction. And so we know that positive ions and negative ions, or opposites, attract one another. So since this chemical reaction is clearly taking place here because of this statement right here, it looks like potassium here is going to want to bond with nitrate, and lead is going to want to bond with iodide. And so the two possible products of this chemical reaction are going to be potassium nitrate, KNO3. Potassium has a +1 charged ion, and nitrate is -1. These two ionic charges add up to 0 already, so we don't need to add any subscripts. And our second product is going to be lead 2, Pb+2, iodide. I has a -1 charge. And since these two ionic charges don't add up to 0, we're going to need 2 iodide ions to ensure that they do. So what is our unbalanced chemical equation? Well, if we take a look, we have potassium iodide reacting with lead 2 nitrate, and this is going to end up producing potassium nitrate and lead 2 iodide. So here is our chemical reaction equation. So we've determined the products already. What we now need to do is balance our chemical equation. Whenever we perform stoichiometry, we have to make sure that our chemical equation is balanced. So let's go ahead and do that. If we take a look here, we have two nitrogens here on the left. So we're going to put a 2 here, giving us 2 nitrogens on the right. If we take a look, we have 6 oxygens on the left. 2 times 3 is 6 oxygens on the right. They're now balanced. We have 2 potassiums on the right, so we're going to put a 2 right here to give us 2 potassiums. This gives us 2 iodines on the left. We have 2 iodines on the right. We have 1 lead on the right and 1 lead on the left. Our chemical equation is now balanced. So now we can start the stoichiometry. We can now determine the mass of the product containing potassium. In this problem here, if we read closely, we wanted to determine the theoretical yield, which is a fancy way of saying the mass in this case, of the product containing potassium. So the products are to the right of the arrow, and so what we're going to figure out is the product containing potassium. That would be this guy right here. We want to know the number of grams of this stuff that will form if 98.9 grams of lead 2 nitrate are consumed. So let's go ahead and start this problem here. In this problem, we have 98.9 grams of lead 2 nitrate. And what we're wanting to figure out is the number of grams of potassium nitrate that will be produced. So in order to figure out the number of grams of potassium nitrate that will be produced, we're going to have to figure out the number of moles of potassium nitrate that will be produced. And in order to figure out the number of moles of potassium nitrate that will be produced, we're going to have to figure out the number of moles of lead 2 nitrate that were consumed. So let's go ahead and first convert the grams of lead 2 nitrate to moles. So in step 1, we're going to convert the, we're going to convert the grams of lead 2 nitrate to moles. So we want to cancel out grams of lead 2 nitrate, so we'll put that at the bottom here. PbNO3 grams of PbNO3 will go on the bottom, and the very first thing we're going to do is convert this to moles of PbNO3. So in our very first step here, what we're going to do is we are going to convert the grams of lead 2 nitrate to moles. And so once we're done doing that, in our next step, what we're going to do is we are going to cancel out moles of lead 2 nitrate. So we'll put that at the bottom of this fraction here. So we'll cancel out moles of PbNO3, and we're going to want to figure out the number of moles of potassium nitrate. So in this step right here, this is our mole ratio step. What we're going to have to do is we're going to have to come up with a mole ratio, a comparison between the stuff that we're trying to find, which is this stuff right here, to the known quantity, which is this stuff right here, and we'll get to that in a second. And last, what we're going to have to do is we're going to have to cancel out the moles of KNO3, and we're going to have to convert that to grams of KNO3, since this question is asking to figure out the mass of KNO3. So in our last step here, what we're going to have to do is we're going to have to convert moles to grams, the moles of KNO3 to grams. And so what's going to go in these empty spaces? Well, let's take a close look here. If we take a look, we're going to have to figure out the molar mass of lead 2 nitrate. So let's go ahead and figure that out. If we take a look here, lead 2 nitrate's chemical formula, and we'll do this right here and hopefully we have room, is PbNO3. So that is our chemical formula of lead 2 nitrate, and if we take a look, this is made up of lead, this is made up of nitrogen, and this is made up of oxygen. We have 1 lead here, 2 nitrogens, and 6 oxygens. And so what we have to do is we have to take 1 times the molar mass of lead, which if we look on that periodic table of elements that just popped up is 207.20. We're then going to take 2 times the molar mass of nitrogen, which is 14.01 if we look on that periodic table of elements, and we're going to get 28.02. And I'm leaving off the grams per mole here. We can just add the grams per mole as the unit to our final answer. We then have 6 oxygens times the molar mass of oxygen, which is 16.00, and we'll get 32.00. And so when we add all of this up, we'll take 207.20 plus 28.02 plus 6 times 16 is not 32.00. We'll go ahead and erase this here. 6 times 16 is going to be 96.00. So we'll take 207.20 plus 28.02 plus 96.00, and we'll get our molar mass of lead-2 nitrate. So we have 207.2 plus 28.02 plus 96.00, and we get a molar mass of 331.22 grams per mole. So we just figured out the molar mass of this substance here. 1 mole of PbNO3 is going to end up being 331.22 grams. What about this next step? In our mole ratio, we're comparing 2 things here. We're comparing the unknown quantity, which in this problem is our potassium nitrate, to the known quantity, which in this problem is our lead-2 nitrate. And so if we take a look, what this chemical reaction equation is telling us is that for every 2 moles of potassium nitrate that are produced, 1 mole of lead-2 nitrate is consumed. We have an imaginary 1 right here. So let's go ahead and fill this mole ratio step in. All we do is look at the coefficient that comes in front of each species in this chemical reaction equation. We have 2 moles of potassium nitrate to 1 mole of lead-2 nitrate. And in our last step, what we need to do is we need to figure out the molar mass of KNO3. And we're running out of room here. We'll go ahead and try to squeeze that in down here somewhere. So we have KNO3, which is made up of potassium, nitrate, nitrogen, and oxygen. There is 1 potassium, there is 1 nitrogen, and there are 3 oxygens. So we'll take 1 times the molar mass of potassium, which if we take a look on a periodic table is going to end up being 39.10 grams per mole. Nitrogen will take 1 times 14.01, and then oxygen will take 3 times 16.00. We end up with 39.10 here. We end up with 28.0, we end up with 14.01 here. 14.01 here. And we end up with 48.00 here. And we're going to go ahead and put this molar mass up here since we're running out of room. So when we add these 3 values up, when we add 39.10, 14.01, and 48.00, we end up with 101.11 grams per mole. So here is our molar mass of potassium nitrate. We just figured it out to be 101.11. That means for every 1 mole of potassium nitrate, it's going to have a mass of 101.11 grams. So in our final step, all we need to do is plug all of this into our calculator. We'll start all the way on the left here, and if we come across a number other than 1 in the denominator as we move from left to right, we'll divide, and if we come across the number other than 1 in the numerator here, we're going to multiply. So we'll take 98.9 divided by 331.22 times 2 times 101.11, and we're going to end up with 60.4 grams of potassium nitrate that will be formed. So, a very long question, a very advanced mass stoichiometry problem, but essentially, in this problem here, if we have 98.9 grams of lead-2 nitrate reacting, consumed in this chemical reaction, then how many grams of potassium nitrate will form? It looks like 60.4 grams of potassium nitrate are going to be formed. If you like what you see, go ahead and click that little bomb in the bottom right hand corner. That's going to subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.